Now I will discuss about some more insertion functions, and after this I will discuss about the deletion functions also. So I hope you remember that on the last turn we have discussed about the linked list structure declaration, wherein the information of this linked list is considered to be of integer type, and the next field is there in every node of the linked list, which is keeping the address of the next node. I have declared a linked list globally. There is a pointer start, which is keeping the address of the first node, and initially the start was keeping a null value, meaning that initially linked list does not have any node. After this I have called several insert beginning functions. I have called the insert beginning functions several times, and the resultant linked list was this one: 600, 500, 400, 300, 200, and 100. So 600 is the first node and 100 is the last node. Now in this lecture I will design the insert end function. Consider that I have to insert at the end of the linked list a value x. So the very first thing should be to reach to the last node, because we are considering that the only thing given to us is the address of the first node. I will have to reach to the last node somehow, then only I can insert a node after that node. So let us again consider that I have a temporary node. This temporary pointer is keeping the address of the first node because I cannot make changes to the start. So for traversal, I will have to use a temporary pointer. Let's say that is temp. Then I have to reach to the last node. The identification of the last node is that its next is null. The identification of the last node is that its next is null. So I will have to reach to till the last node, which is having its next null, by just checking a condition. If temp is not null, then move to the next node by temp equals to temp.next. Once I have reached to the last node, I will call a get node function. Let's say I have another node pointer which is p. I can make a call to the get node function. Get node function will allocate the memory and will return the address of the allocated memory. Let us accept that in p pointer. Then in the information field of this node, put the value x. Since p node, the node which I am creating, is going to be the new last node of the linked list, so keep the null value in the next field of this node. The only thing remains is now to link the previous last node with this one. Previously the last node was temp, because by the traversal I have reached to the last node. So temp is now keeping the address of the last node. In the next field of the last node, I can keep the address p, which is a newly created node. I have not declared p yet, so type of p will be struct node star. It means a node pointer, because it is going to keep the address of a node. If we call a get node function that returns the address of the node, that will be accepted in node pointer only. So by this way, I have called the insert end function. Now let us call a function insert end now. After these many insert beginning function, let us now call the insert end function. Let's say that at the end I need to insert a value 200. So after this I will traverse. Just to check this, first traverse before the insert end function and then traverse after the insert end function. So this is the traversal before the insert end function. There may be some error because of which it is going in the indefinite loop. Let us find out that condition. Okay, so the address of the identification of the last node is that its next is null. So I will have to write a condition while temp.next is not equal to null. So you can see that the first traversal is before the insert end function and the next traversal is after the insert end function. We can check it by some more function calls to the insert end function. Let's say after insert end 200, I'm now calling insert end 700. So the last node is now 700. Now suppose since 200 is duplicated value, let us now change it to 800. So now I have the distinct values here now. Now suppose in this linked list, I want to insert a node after 400. So I'm not going to insert a value at the beginning nor at the end, but somewhere in between. Let's say after 400 I want to insert a value, let's say 350. So first I will have to find out the address of this 400 node. I do not know the address of the 400 node. Only thing known to us is the address of the first node. So somehow I will have to find out the address of the 400 node. Then I can make the insertion after this 400. Fine. So after this, let's say we are going to call a function insert after that will insert a node 350 after 400. Means there is a node which is containing the value 400. It will insert a node containing value 350 after the node 400. Then we can traverse to check if my traversal is working fine. Now let us design this insert end function. In the insert end function, there are two values passed. First is the node after which the insertion is required to be done, the key value of the node, and then the value to be inserted, that is x. So I will first have to check where the value y is present in the linked list. To have it, again take temporary pointer which will traverse the linked list and will find out where y is located. Let's take a temporary pointer temp which is keeping the address of the first node. Find out where the information y is present. So while temp is not null, if the data value of this temp node matches with y, it means I have reached to the target node. In that case, I will break. I will break from this loop because I have found the address after which I have to make the insertions. So in this linked list that I have made, if you remember, the first node is containing the value 600, second one 500, next one 400, and then after the 400 I have to insert a value 350. So it means if temporary pointer is keeping the address of this node having value 400, then I will have to insert a node after this node. Hence the link should be between 400, 350 and 300 because the new value is going to be 350, what we have taken as an example. So to insert this, I will first have to create a link between 350 and 300 and then 400 and 350. So there are two links, those are required to be established. So if I have not inserted this 350, then temporary is the address of 400 node. The next field of temporary should be containing the address of this node having 300 value. So first make a node by calling a getNode function. Let's keep the information x here, and then establish the links between these nodes. So the node 300 will have the address temp.next. The node 300 is having address. If this node is having address temp, then obviously in the next field of this node it will have the address of this node. So temp.next is the address of node 300. If I'm going to insert a node 350 in between, then the next field of this 350 node should contain the address of this node, which is temp.next. So p.next is keeping the address of 300, which is actually temp.next. Now let us link these two nodes. This node is having address temp and this node is having address p. We have recently created this node. So next field of temp will now contain the address of p. This way we have established a link between 400, 350 and 350 and 300. All the nodes having values 400, 250 and 300. So what we did, let us recall this. We have searched a node having information y. We started the search from the first node. We have traversed the linked list and found the address of the node containing y information. Having found that node, I have created a node, inserted the value x there, and then tried to create the link between newly created node and the next node and newly created node and the previous node. So these are the two pointer adjustments that we have made. If I have not inserted 300, beforehand 400 was temp, the address of 400 value node was temp. Obviously this will be temp.next. 300 node will have the address temp.next, and then we have created the link. We have to create the link between 350 and 300. So this node is having temp.next address. This is the newly created node, which is p. So the next field of 350 node should contain the address of this node, 300. So p.next is equals to temp.next. After this is the temporary node. So temporary.next means the next field of this node will contain the address of the newly created node. Let us now check if this is working fine. Let's make some changes here. Just recall that after the insert beginning functions, I have called the traverse. Then After this, I have called two insertion functions with values 800 and 700. Then traverse the linked list. After this, I have called the insert after function and then insert, then traverse. Key is undeclared in this insert and function. Let's declare this key. Insert after function. Sorry. There is some logical error. Let's check them. Oh, if the value of a node is not while, then I will have to approach to the next node. So in the else, I have to write temp equals to temp dot next. And you can see that after 400, 350 value has got inserted. You can check with some other examples also. Let's try to insert a value 150 after 200. Value 150 after 200. So 200, insert a value 150. You can see that after 200, 150 as well. Now let us discuss the deletions functions also. And the very first function let's design is the delete beginning. Meaning that we have to delete the first node. Since we have to delete the first node, so let's take a temporary pointer temp. Temp keeps the address of the first node. So temp keeps the address of the first node and we have to remove the first node only. Now once we have to delete, if we have to delete the first node, obviously after the deletion, start shift to the second node. After deletion of the first node, start will shift to the second node. Now we have shifted the start to the second node, so let us destroy the second node. This can be done by calling a function free. If we can allocate the memory at runtime using the malloc function, we can deallocate the memory also at runtime using the free function. Let us make a practice that if we are going to delete any node, I will return the value of that node. Fine. So you can store the value of this node in some x variable and then return this value. X is declared from our side, so let us declare this x as integer value. Delete beginning function is returning an integer value, so its return type should be integer. So let us summarize what we have done. We've taken a temporary pointer which is keeping the address of the first node, and then after the deletion of the first node, start will move to the next node, hence start equals to start.next. Temporary node is going to be deleted, so let's keep the information of this temporary node in some x variable. Then free this node at runtime to deallocate the memory. and finally return this value. Now here, up to now, what was the condition? Let's now remove the first node by calling the delete beginning function. So I've called the delete beginning function, and after the delete beginning function, let's traverse this thing list. So you can see that the last one is after the deletion of the first node. 600 is got deleted. If we call another delete beginning function, then 500 has also gone. If we call another delete beginning function, 400 will also disappear. Right? Now, if we want to print what value has got deleted, you can save these values in some, let's say, zx variable, and then you can print them by one. So after every deletion, you can print these values. You took x from your side, so declare x as integer, and then finally you can see that the first deleted value is 600, second one is 500, next one is 400, and after deletion the linked list is this one. Now if I design the delete end function, which will delete the last node from the linked list, so this is the delete end function. First, try to understand what this delete end will do and how it will be done. Suppose this is the linked list, so I have to delete the last node which is containing the information 500. Now if I have to remove this 500 node, or the node which is containing the information 500, then some changes will be there in the node 400 as well. Earlier the last node was 500, hence the next pointer of this node was null. This is the identification of the next node, that last node, that its next is null. So once I will delete this 500 node, the new last node will become this 400 node. So we will have to make the next field of this 400 node also as null. So to make this, let us consider that I have a concept of the previous node. For example, if I say that I am at 200 node, then I should have the address of the 100 node as well. If I have the 300 node, if I am at the 300 node, then I should have the address of 200 node as well. If I am at the last node which is containing the information 500, then I should have the address of the 400 node as well. So I am going to use the concept of the previous node. Let's consider that there are two addresses, P and Q, two pointer variables declared, and this P is keeping the address of the first node, and Q is the predecessor node of P. Q is the previous node of P, and initially it will be null. If P is at the first node, obviously there is no previous node of this, so Q will be null. If P is at 200, then Q is at 100. If P is at 300, then Q is at 200. Now let us traverse this linked list. I will traverse this linked list to reach to the last node. And the identification of the last node is that its next is null. So by the time I have not reached to the last node, I will keep on moving to the next nodes. For moving to the last node, for moving to the next node, you will write a statement P equals to P dot next. So obviously we have to traverse the linked list until I reach to the last node. But I have to store the address of the previous node also. So let's do Q equals to P, by which I can store the address of the previous node. If P is at first node and Q is null, now P is going to move to the second node, then beforehand I will make Q to point at the first node. So first Q at the first node, and then P has moved to the next node, second node. So this way, Q is always the predecessor of P. Once this loop will finish, I will be at the last node. It means P will be keeping the address of the last node and Q will be keeping the address of second last node. So the very first thing that I should do is to set the address of the second last node as null, because last node is now going to be deleted and second last node will become the last node. After this, store the information of the last node in some X variable, then free this node by calling a function free, and then you can return the value X. Fine, let us just summarize this. I'm taking the concept of the previous node initially. Current node is at the first node, and then Q is null because there will be no predecessor node of first node. I have to reach to the last node, so identification of the last node is that its next is null. I will move this to the next pointer if I am not at the last node. Along with this, I am moving the Q as well, such that it always keeps the address of the first node. Once I have reached to the last node, the next field of the second last node will be set to null. I will store the information of the last node, will free that node to deallocate the memory, and will return the deleted information. So now call the delete end functions as well. So this delete end function, after this we will traverse. X is undeclared, so let us declare this X. You can see that the last node is 700 and we have deleted this 700, and after this the traversal is this one. You can check it another time. The first time when you have called the delete end function, it has deleted 700. Now it has deleted 800, and after the deletion, the traversal is this. So the way you have deleted the first node and the second node on the third node and the last node. You can delete any of the node in between. So you may prefer to design the delete after function the way we have designed the insert after function. Thank you so much.